Hello, and welcome to the Foundations of Music. In today's lecture, we will be discussing a second part to a two-part series on rhythm. If you have not seen the first part, I recommend watching that lecture first. In this lecture, we will be discussing tempo markings, dotted rhythms, beaming, and how their relationships form between all these concepts. Pictured in this first slide are some of the concepts we discussed in the previous lecture. A good understanding of these concepts will aid you as we move forward with this lecture to some more advanced concepts in rhythm. As with many of our concepts this far, we will be revisiting Happy Birthday to understand many of these new ideas. The first one is the tempo marking. We've seen this at the very beginning of Happy Birthday, above the first measure or the time signature. This is the note with an equal sign and then a number. In this instance, it is saying that a quarter note equals 120. The tempo marking is helpful for determining the speed of the pulse. Again, you use the time signature to figure out what note head represents the pulse. With Happy Birthday, we can see that it is in 3/4. The 4 on the bottom tells us that the quarter note represents the pulse. And so in the tempo marking, we can see that a quarter note equals 120. The implied units for 120 are beats per minute, or BPM. You will almost never see a BPM marking next to the number, but it is always implied that the number that the note equals is beats per minute. So in this instance, there are 120 quarter notes that fit into 1 minute of time. Something that is a little bit difficult to put into words, but very important for performing music, is that we always divide time equally. So when we say that there are 120 beats per minute, those 120 beats are evenly spaced out across the minute. That is what gives us the pulse. If they are not evenly spaced, then that is the equivalent, as we said in the previous lecture, of arrhythmia if your heart were not to beat at regular intervals. That would be very unhealthy. I have an example of this below in this slide. The easiest way to visualize this is if the quarter note equals 60 beats per minute. This is easy because there are 60 seconds in a minute. So if you have 60 beats per minute, then every quarter note will last for 1 second of that minute. And so the top pie chart represents how much time each quarter note would have. We will listen to what that sounds like now. The bottom pie chart shows what happens if you just try to squeeze all of the beats into 60 seconds without any regard for an equal division of the time. It would be incorrect to play all 60 beats in the minute as fast as you can and then wait for the minute to be over before playing the next 60 beats. That would sound like this. As you can probably guess, we still have quite some time left in our minute. It is important to remember that we always want our pulse, or our beats per minute, to be spaced out as evenly as possible. Of course, not everybody can simply know how fast a tempo is, or know what the beats per minute sounds like of some obscure number like 156 or 33. Even professional musicians may not have all of the tempos internalized in their body. So how do we know how fast a tempo should be? Well, we have many tools to help us with that. Before the digital age, many musicians would have a physical metronome. A metronome is something that lets you set a click sound to a beats per minute rate, and then you can listen to it and then play along with your instrument. Today, there are many digital metronomes that you can find for free in the App Store. I've put a couple of the apps down at the bottom of this screen. I recommend finding a metronome. You can download one from an app store. You can find a metronome video on YouTube or an in-browser metronome. If you just Google it, I'm sure you can find something. The best metronomes are ones that let you set the specific number that you are trying to find. Although if you are hard-pressed and you absolutely cannot get a metronome, there are some ways of figuring out how fast a tempo should be. For example, if the tempo is 60, well, we know that there are 60 seconds in a minute. So if you have 60 beats per minute, you can just think 1 Mississippi, 2 Mississippi, 3 Mississippi, and that's your pulse. If your tempo is 120 beats per minute, then you just double that. So you go from 1 Mississippi, 2 Mississippi, to 1, 2, 3, 4, 1, 2, 3, 4. It's double the speed of 60 beats per minute. And then everything in between, you can use those as references. So if I have a beats per minute of 136, I can do 120 because I know what that sounds like. And then I can just speed it up a little bit. I might get to around 130 or 140. It won't be perfect, but it will be close. And you can do that for slower tempos. If you have a tempo of 40 beats per minute, we'll start out with 60. And then slow it down yourself. You will not be exactly right, but you will be close. And that's good enough sometimes. Before we go further into that subject, we should first discuss beaming. I'm sure we've seen this all over our music before. We have yet to bring it up, but beaming, or beams, are the horizontal lines that connect the vertical stems of a note head. You will see beams on any note that has a flag attached to its stem. This includes, but is not limited to, eighth notes and 16th notes. These are the more common ones that we will see, although in theory, every division below eighth notes will have one additional flag. So eighth notes have one flag, 16th notes have two flags, and then theoretically, a division below that would be 32nd notes, and a division below that would be 64th notes, and so on, each one with an additional flag. Any note that has a flag can be beamed. There are a couple reasons for using beaming. One great reason is that it cleans up the sheet music. It makes it clearer and more easy to read. Pictured at the bottom of this slide, I have two examples. The measures sound the exact same. They are the same rhythms. The top two, are both full of eighth notes, but the one on the right is beamed and the one on the left is not. Having a flag on every single note clutters up the measure. Below that, we have 16th notes. Again, both of the examples on the very bottom have 16 16th notes in them. But the one that has beams is easier to figure that out. This also helps show where the pulse is and where the smaller note values belong. Pictured in this slide are some examples of good and bad uses of beaming. In this first one, we have 16th notes, but every 16th note is beamed. We do not do this. 16th notes and 8th notes are generally only beamed within the pulse that they fit into. So, if our meter is in 4/4, then we have 4 pulses. So we can fit 4 16th notes inside of a pulse. This first one on the left has everything beamed together, and it's very hard to decipher where the pulse lies. This is what that sounds like. Maybe that sounded okay to you, but let's hear the version on the right that has each pulse beamed on its own. Which one did you prefer? There is a time and a place for everything in music, and so sometimes you do want every single note in a measure to be completely even with how loud they are, how much emphasis they get. But for a lot of the time, you want an implied, stronger beat. As we talked about with meter, some pulses are stronger and others are weaker. When we use beams, the first note in a beamed grouping of notes has an implied strength that the others do not get. And so when we have each beat beamed together in its own little cluster of 4 16th notes, we know that the first one in every beat is going to be a little stronger. In this blue box at the bottom of the slide, I have a more practical reason for why you would not beam a whole measure together, and that is communication. If you were playing with other musicians and you wanted to start on a particular beat of a particular measure because you were practicing a tough section of music, or if you're in a band and your director or choral conductor asks, "Hey, what is the first pitch that you play on beat 3? This example on the left, it's very hard to tell where beat 3 is. You would have to count, starting on the far left, all the way up to the 9th note in the sequence. For the example on the right of that, where each beat is beamed separately, you can just go to the third grouping of notes that is beamed and say the pitch of the very first 16th note. Here we go to beat 3, which is clearly identified by the beams, and the first pitch in that grouping is an F. So the first pitch of beat 3 in this instance is an F. The final example in the bottom right of this slide usually goes without saying, but you can never know, some people will make this mistake, is that you do not beam across the bar lines. All beaming should be contained within their own measures. Again, there is a time and a place for everything in music, so some of us that are more experienced in music may have encountered music where there is beaming across a bar line, but this is not commonplace, and it should not be common practice. You should now have an understanding of how 8th notes get beamed and how 16th notes get beamed. But what is now important to understand is that you can beam together notes of different values, meaning you can connect an 8th note and a 16th note with a beam. If there are 4 16th notes in a pulse, then you can fit an 8th note in there. As you can remember from our rhythm tree, an 8th note is the same as 2 16th notes. So pictured here on the bottom left, I can show you that you can use an 8th note to replace the first 2 16th notes in a grouping of 4. You can use an 8th note to replace the last 2 16th notes, or you can use an 8th note to replace the middle 2 16th notes in a grouping of 4. On the right, I have an example of what this looks like, both without beams and then with beams. The first one is 1/8 note followed by 2/16 notes. This would be the same as the 8th note taking the place of the first 2/16 notes in a grouping of 4. The middle example has 2/16 notes followed by an 8th note. The bottom example is a 16th note, an 8th note, and then a 16th note again. Take special note of how the beaming works, especially in the last example. With the 8th note in the middle, the second flag of the 16th note starts out as a beam and then cuts off. The 8th note is placed in the middle, and then the 16th at the end has its second flag poking out just a little bit, and then it also cuts off. Compared to the first two examples, where you have the second beam connecting the 2/16 notes. Just like how every division below an 8th note will develop another flag, you will also use an additional beam. Our next concept is dotted rhythms. This can be a little intimidating at first if you've never encountered them before, but they are quite easy and we encounter them quite often. They're very common in music. Almost all of us have grown up singing them even though we might not know them, and we have been looking at them this whole semester. At the bottom, I have again, happy birthday, and the very first note is a dotted rhythm. And as the slide says, put plainly, a dotted rhythm is when you put a dot next to a note head of any value. These 4 bullet points should tell you everything you need to know about dotted rhythms. First, a dot adds to the rhythmic value of a note, meaning if you see a note that has a dot on it, it's going to last for a longer amount of time as it normally would without a dot. Second, you can put a dot on any note value. Literally any note can have a dot placed on it as long as there's enough space left in the measure for it. Third, a dot does not extend a note's rhythm by a set amount, meaning a dot will be worth different amounts depending on the note that it is placed on. Fourth, and this is a very important one, a dot is worth half of the value of the note it is attached to. In order for this to make sense, you will have to have a firm understanding of the rhythm tree and how some notes divide down into other notes. In our first example, we have a dotted quarter note. A quarter note is worth 2/8 notes. So half of a quarter note is an 8th note. So when you put a dot on a quarter note, that dot extends the value of a quarter note by 1/8 note, making it the same as 3/8 notes. This also applies to the half note. A half note is worth 2 quarter notes. So a dotted half note gets its value extended by a quarter note. A good way to double check this is by looking at the rests remaining in the measure. For our dotted quarter note, we have an 8th rest followed by a half rest. Then the 3/8 notes leaves us with an 8th rest, also followed by a half rest. This tells us that they are taking up the same space within the measure. We will now combine 2 absolute statements that I have made in this lecture. The first statement is that any note value with a flag can be beamed. The second statement is that you can place a dot on any note value. This means that you can beam dotted rhythms, or you can put a dot on a rhythm that has a beam. To illustrate this, we will use the dotted eighth note. Half of an eighth note is a 16th note, and so when you put a dot on an eighth note, you are extending its value by 1/16th note. Or a dotted eighth note is the same as 3/16th notes, as pictured here on the right side of the slide. A dotted eighth note can either take the place of the first 3/16th notes, or it can take the place of the last 3/16th notes. If you do that, you can see here how the beaming would work. So on the bottom left, we have a dotted eighth note, and it is beamed to a 16th note. And that takes up the full pulse, one whole beat. And in the bottom right, we have a 16th note tied to a dotted eighth note, which takes up the same amount of space. This leads us to counting, one of the most important skills for any musician to have, whether they play the drums, the piano, or a trumpet or violin. They must have the ability to count, internally and externally. The rhythms of the music are going to come first before they figure out what pitches to play. So it's important now for you to know how we count music. The note value that represents the pulse, or the bottom number of the time signature, is counted with the numbers of the measure. So in a measure of 4/4, the bottom number says 4. So the quarter note is going to get the numerical representation of each beat in the measure. 1, 2, 3, 4. As we divide that down to its next subdivision, eighth notes, those main pulses of 1, 2, 3, 4 stay the same. But the extra eighth note in between we call and. Sometimes this will be written as a plus sign or the and symbol. And this would be 1 and 2 and 3 and 4 and. If you go down to one more subdivision, the 16th notes, the numerical representations, the and are still in the same places they were before. But now there's a 16th note in between each of those. The first 16th note we call E, and the second 16th note we call A. So on the first pulse, we would read that as 1 E and A. And then you just go up the numerical for each pulse after that. So 1 E and A, 2 E and A, 3 E and A, 4 E and A. Again, because when we divide time, we're making sure that every pulse and every division of every pulse is represented equally across time. The time that it takes to say 1, 2, 3, 4 does not change. I will demonstrate this by counting just quarter notes, and then eighth notes, and then quarter notes again. Notice that the numbers that I say do not slow down or speed up. They remain the same. 1, 2, 3, 4, 1 and 2 and 3 and 4 and 1, 2, 3, 4. The middle example demonstrates this with 3/4 as the time signature. This will be the same as the previous one, but there are only 3 beats in each measure. So if we count it, it would be 1, 2, 3, 1 and 2 and 3 and 1E and a 2E and a 3E and a. It's important to note that the quarter note will not always be the pulse. Here I have an example that is in 4/2. Because 2 is the bottom number in the time signature, I know that a half note represents the pulse. And whatever represents the pulse, we use the numbers to count them. The top number is 4, so we know that there are 4 of those half notes in a measure. So written out here, using half notes, we would say 1, 2, 3, 4. And then when you divide those half notes down into quarter notes, that would become 1 and 2 and 3 and 4 and. That concludes everything that we will be discussing in this lecture on rhythm. There are still some concepts that are yet to be discussed, that are more advanced, and we may discuss them if we run into them in the future. But as of now, you should have a good foundation for approaching most basic rhythms and the ability to confront most basic pieces of music on your own and be able to read them. If we revisit Happy Birthday, you should now have all the tools available to successfully read the rhythms and the pitches. You understand the time signature. It's in 3/4. So there are 3 pulses in a measure, and the quarter note represents each pulse. We know what the tempo marking is telling us. The quarter note will equal 120. So there are 120 quarter notes in a minute, which is twice as fast as 60, which is 1 second per minute. And now you can read dotted rhythms, which is the very first thing you see in Happy Birthday. In fact, when you say the word happy in Happy Birthday, happy, you are doing a dotted rhythm. To finish this lecture, try clapping the rhythm to Happy Birthday from start to finish. But don't sing it. See if you can only perform the rhythm without the aid of you already knowing how the song goes. This will be good practice for your assignment.